All right, here's video number 3, which is gonna involve a couple examples from the third page of the guided notes for section 9.1. Let's get into it. All right, so what do we got here? So here we have another compound inequality, this and this, and we're looking for all of the solutions that are in this or in this. So remember, that keyword or indicates we're looking for a union, or you can think of it as we are adding all of the elements of this to all of the elements of this. So you can be in the solution to this compound inequality as long as you are in this or you are in this. Just one or the other, doesn't have to be both. So let's take care of this part first. Let's kind of simplify down our two simple inequalities. So if I subtract 3 from both sides, negative 4x is less than 13. Divide both sides by negative 4. That's going to reverse the direction of the inequality. It's going to give me x is greater than 13 or negative 13 fourths. Okay, so here is our first sort of inequality that we're gonna graph in just a second. This one right here, it's only going to be one step, but I do have to be careful because I'm dividing by a negative. That's going to give me x is greater than negative 3x, right? So that wasn't too bad. Okay. So next, what I'm going to do is I'm going to graph these two inequalities and sort of see what I'm dealing with. So I know that negative 3/2 is about negative 1.5. 4 goes into 13, 3 1/4 times, right? So this one is actually less than this one, right? So that's my two, my two places on the number line. This one is further to the left than this. Yes. Okay. So what's the deal with this one? This is x is greater than this, strictly greater, so that's going to be like that right. Yeah. Here x is greater than negative 3/2, so that starts from here and also goes to the right. And so what we're looking for is, what are the solutions? What are the places or on the number line that include this or this, just one or the other? And it looks like, well, my left boundary is going to be this number here. Okay, there's nothing in any of these that goes any further to the left than negative 13 fourths. Okay, so there's my left boundary of my solution. Parentheses because it does not include negative 13 fourths. And it goes to the right, there's no gaps, no gaps. Here's where this other one picks up. No gaps, no. This one ends, or actually it doesn't, it just keeps going, right? And then this kind of picks things up as well. So after a while, both of these sets are included. So that means off to the right boundary just keeps going until infinity, right, with a parenthesis like that. So the union of these two is this, okay? Starts at negative 13 over 4, doesn't include it, but then includes everything off to the right forever and ever. Right. So that's that. The next two examples, the last two examples here are going to be kind of like some story problems. Not super intense ones, but they're word problems. So let's take a look at those. What do we got? So example, the one that we didn't do yet would be the sum of a number. Oh no, the sum of twice a number. Sum of twice a number and 11 is between which two numbers? 21 and 30. So that's what it says in this example right here. Okay. So we have to first take a look at this and turn it into some kind of you know, like mathematical stuff. I know sum is adding, so I'm going to be adding two things. Which two things am I adding? Twice a number and 11. Okay, so twice a number, I could use any variable I want for this unknown number, but I'll choose to use x. So twice a number is 2x. The sum of twice a number and 11 will be 2x plus 11. Okay, so that kind of takes care of the first part of the sentence. Now, this whole situation they're saying is between these two numbers. Is between these two numbers. So if it's between, and it doesn't include, the symbols that I'm going to use are just the greater than symbols, not greater than or equal to, because it's between, it's not including. Between 21 and 31. Okay, so whatever this is between these two numbers right here. And I think that's it. So this is kind of like in words, and this is in symbols. Okay, first step is done. Now I just need to do the moves needed to simplify this. And so the way I simplify this is whatever I'm going to do, I'm trying to get x by itself in the middle part of this compound inequality. Whatever I do in the middle, I have to do to the left and the right. So I'm going to subtract 11 from left, right, and middle. Okay, 21 minus 11 is 10. It's less than 2x. It's less than, that becomes 0. 31 minus 11 is 20. Okay, so now I've boiled this down to 2x, or 10 is less than 2x is less than 20. Divide each piece by 2, I'm going to get 5. It's less than x is less than 10. And there we have the solution. All of the numbers that meet this requirement are the numbers between 5 and 10. On a graph, it would look something like this. 10 are the two numbers that I'm going to be most interested in on my graph, and open circles, and it's x is greater than 5, and x is less than 10, so it's everything between those two numbers, okay? And if I really want to be thorough, I could also represent this in integral notation, okay? I know the left and the right, you know, kind of grouping symbols are going to be parentheses because we're dealing with less than, not less than, greater than. And it's just these numbers, right? All the numbers between 5 and 10. So here's integral notation. Here's kind of like, you know, kind of inequality notation. Here's the graph. I think that covers everything, right? So good. All right, so last one is kind of a bigger story problem. And I actually find this problem to be helpful, not just because it's a good example of how we might use inequalities in real life to solve real problems, but the type of problem, the type of situation that's being described in this last example is something that you might find yourself thinking about when you kind of get to the end of a class and you're trying to figure out your situation with your grades based on the tests you've taken, right? So this says the syllabus for a bio class is the average of the chapter tests is 60% of your overall grade. The final exam counts for the remaining 40. You have an average of 89% for your chapter tests. What would you need to score on your final exam to earn a final grade between 80 and 90% in the class? So we're trying to get between 80% and 90%, okay? Which, in terms of decimal numbers, not percentages, we're trying to get between 0.8 and 0.9, right? The final exam counts for the remaining, let's see, what is it again? You have an average of 89% on chapter tests. Chapter tests is how much? Chapter tests is 60%. So you've got 0.6 times 89, right? right? So you've got 89% of your chapter test, that's 60% of your grade. Multiply this together, and you get, sorry, I've got to use my calculator for this, 0.6 times 89 equals 53.4. So you're kind of like, wait a minute here. Oh, I should have done this. 0.89 times 0.6 equals. So I should have put a decimal here, right? So I'm turning these percentages into decimals. 0.6 times 0.89 is 0.534. Okay, so the contribution to your final grade is from your chapter test is 0.534. But you also have your final exam, and what does it say about the final exam? The final is 40%. Final 40%, which is 0.4. And you don't know what you're going to get on the final. That's what you're trying to figure out. So we're going to represent that final as x. So 0.4x is what goes in here, right? And I think we've got it, right? So chapter test plus final exam is the final grade. You're trying to get your final grade to be between 0.8 and 0.9. Now we just have to solve this for x to see what the situation is. So if we subtract 0.534 from both of these, from the middle left and the right, 0.8 minus 0.534 is 0.266. It's less than 0.4x. It's less than, well, that would just be 0.366, right? Okay. Erase this stuff real quick because it's out of my way. Right. So now I just have to divide everything by 0.4 and I'm good, right? 0.4x. 266 divided by 0.4. So that would be 0.665 is less than x is less than 366 divided by 0.4. 0.915. Which in terms of percents would be a 66.5% and a 91.5%. So if you wanted to get a final grade somewhere between 80 and 90% under these circumstances, the final grade on your final exam would have to be somewhere between 66.5% and 91.5%. So that's how you would go about figuring that out, right? Okay, so I think that is it. I hope this was helpful. Hit me up in some office hour meetings if you want to talk further about this or anything else. But that is all I have for the day. Cheers, everybody.